Hi guys, welcome to our notes for 7.1 on similar polygons. So the first bit of our last unit, similarity of figures. So remember, polygon just means some sort of many-sided shape. So here's a polygon, that's a triangle. Here's a polygon, that's a square. All right, so when you draw an image of something that's either larger or smaller than the original, what you're doing is creating an object that's similar to the actual object. So not the same, because the sizes are different, but similar. So two figures are said to be similar if they have the same shape, so your angles and proportion of sides, but are usually different in sizes, right? So taking a look here. Here I have two similar triangles, and here I have two similar squares. So we have a couple rules. So for two figures to be similar, they have to have corresponding angles that are congruent. That just means equal. Okay, so angles have to be equal, sorry. So corresponding angles must be equal, and corresponding sides must have the same proportion. Okay, so sides must be proportional. Okay, so if I wanted to see if these were similar, I could take a look at their angles and the proportion of their sides. So taking a look at their angles first. So grabbing my protractor, lining her up. So this angle right here, so angle BCA or just C, is 30 degrees, and the corresponding angle, so the EFD angle, is also 30 degrees. Okay, so far so good. So here my corresponding angles are equal. Here we have a right angle corresponding with this angle, which are 90 degrees. Okay, so far two angles are equal. Checking our third one. So angle ABC is 60 degrees, and over here EDF, the corresponding angle, also 60. So if I take a look, all of my angles are the same. Okay, so far I'm good because my angles are equal. My corresponding angles are equal. And taking a look at my sides. Okay, so here I have 6 feet at this AB, which corresponds to this side on this triangle. So ED, so 6 foot to 3 foot. Okay, so 6 to 3, that is a 2 to 1 ratio. So divide both those by 3. So 6 divided by 3 is 2, 3 divided by 3 is 1. So this ratio is 2 to 1 for those sides. And taking a look, 10 feet and 5 feet. So a 10 to 5 ratio. Divide by 5. 10 divided by 5 is 2. 5 divided by 5 is 1. So also a 2 to 1 ratio. Okay, so my sides are proportional. So my shapes are similar. So I can say that ABC, so triangle ABC, is similar to triangle DEF. Okay, so this little squiggle, since they're not equal, I can't put an equal sign. I can't put a line because that'll look like a subtraction or something. So the symbol for similar is this squiggle. So this squiggle means that you have two shapes that are similar. So triangle ABC is similar to triangle DEF. Taking a look at the squares here. So all squares are going to have 90-degree angles. So I already know my angles are going to be okay. So my angles are equal. Right? So let's just take a look at our sides. So this side is a 2 to 4 ratio. So you can write it like this with the dots as a ratio, or we can write it as a fraction. So let's do 2 over 4, which equals 1/2. And let's take a look at these. So here is also a 2 and 4 equal to 1/2. So here our sides are proportional because they have the same ratio. So the squares are similar. And we'll just use the shorthand way of writing similar. So your squares are similar. Good, good, good. Okay. An example of where you would actually need to use this is, let's say you have a magazine. So we have Debbie working for a magazine. She's adjusting the dimensions of some images to make them fit into the article, and she's kind of unsure if she changed the length and width properly. So she wants to make sure that she's changed it by the same amount so that she has similar images. So this would be a problem if, for example, we got something that looked like this. So as we can see, we have changed the width by a different ratio than the length, and we get an image that gets distorted. So Debbie doesn't want a distorted image. She wants them to look proper. So we should check if they are similar. So what's the ratio of the length? So the horizontal measurements. So our lengths, so the longer sides, are 4 and 6. Okay, so you can, remember, set it up like this or like this. It really doesn't matter. So a 4 to 6 ratio, so divide by 2 is a 2 to 3, or same thing over here, 2 to 3. Let's use fractions. So the ratio of the length is 2 over 3. So the ratio of the widths, if I take a look, I have 2 centimeters to 3 centimeters. Okay, so 2 centimeters to 3 centimeters is also 2 over 3. So the same ratio has been used. Yes, it has. So are the two photographs similar to each other? Yes, Debbie doesn't have a problem. They are proportional. There will not be any picture distortion. For the second example, a family has built a home and they designed a backyard garden in the shape of a trapezoid. So they decided to move and they wanted to build the exact same garden except for larger. The two gardens are sketched below. So are the two backyards similar to each other? So we need to check first our angles or our sides and then check the others. So checking our angles first. So our angles should be equal. So taking a look, here we have 109 degrees. The corresponding angle on our other shape is right here, and it is also 109 degrees. So far, so good. Next angle that we're given is this 71 degrees. This angle right here is 71 degrees, so its corresponding angle is equal. So our angles are all right. So angles are equal. So far, so good. So let's check our sides. So here we have side AB is 7.2, and side EF would be its corresponding side. So here's top. Our trapezoid is sitting the same way, so we don't have to do some weird flipping. So 7.2 and 10.8. Now, this is not going to be good to set up side by side. We're going to want to make this into a fraction and then actually divide these two numbers to see what ratio we get. So 7.2 divided by 10.8. And it doesn't matter which one you put top and bottom. I usually put my one on the left on the top, the one on the right on the bottom, just because that's how you would normally set up a fraction. But it really doesn't matter. So 7.2 divided by 10.8. If you put that into your calculator, you get 0.6, basically 0.6 repeating, okay? So we'll just say 0.6 repeating itself. Okay, checking our other sides. So we have a 10 meter, and corresponding with that is our 15 meter. Okay, so we have 10 to 15, so 10 over 15. 10 divided by 15, and once again, we get 0.6 repeating. Last side we have to check. So 13.6 corresponds to 20.4. Divide those two numbers, and once again, you get 0.6 repeating. So taking a look, our sides all have the same ratio, so our sides are proportional. So another check. So the backyards are similar. Yay. Okay, don't know why I have A and no B. So your assignment is horrible. You're going to see why I don't usually use the textbook. The questions are the worst. But anyway, it will be on page 232 to 234, questions number 1 to 6. All right, good luck, guys. Bye.